I'm going to start chapter 2, section 4, talking about linear functions. All right. So remember that when we're talking about those linear functions, that's just a fancy way of saying that the graph of the function given is going to be of a line or the highest degree the function is presented of x is the first. So example, if we give an f of x is equal to ax plus b, or y is equal to mx plus b. In both cases, b is the y-intercept, the number in front of x is my slope on my rise over run. Remember, we also talked about intercepts themselves being x and y-intercepts. If we're dealing with the x-intercept, this implies that y is 0, or the x-intercept is the order pair x, 0. Obviously, the x-coordinate is going to change depending on the intercept itself or the function itself. When we're talking about our y-intercept, this implies that my x is 0, and the order pair associated with that would be 0, y. Keeping in mind the second number in the order pair, always my y coordinate. So if we're given a problem like so, let's say we're given the equation y is equal to negative 2x plus 6. Here, 6 is my y-intercept, negative 2, or the number in front of x, would be my slope. Now, the domain for this function, before we graph it, well, you know what, matter of fact, let's go ahead and graph it now. So, if we're sketching this graph, this is a shorthand graph pretty quickly. And we're going up to our y-intercept, which is 6. So we can go up 1, 2, 3, 4, 5, 6. That's a point on my graph. That's my y-intercept. My slope, negative 2. Remember, this means we're going to go down 2 and to the right 1. So from this point, we're going to go down 1, 2 to the right 1. It's another point on my graph. Once we have 2 points, it's enough for us to define a line. We just have to connect those points with a line. This is the graph of the equation. Y equals negative 2x plus 6. In this case, my domain, the entire real number system are from negative infinity to infinity. And the range, also the entire real number system are from negative infinity to infinity. So it reaches left and right forever, and it goes up and down forever. From negative infinity to infinity, left and right, and from negative infinity to infinity, up and down. Another example that we can be given, let's say we're given the equation y is equal to negative 3. Let me graph this one. All right, so if y is equal to negative 3, that means no matter what the x value is, y is always negative 3. This is going to give us a horizontal line. Now the line goes from left to right. So if we're graphing this, it's negative 3, so we'll start here. It's my x-axis, y-axis. Down to negative 1, negative 2, negative 3. Graph of this line says that no matter what the x value is, my y is negative 3. So this is a perfect horizontal line. Here, domain of this function, the entire real number system are from negative infinity to infinity. Well, the range of this function is simply the set containing negative 3. That's the only y value for this entire function. Yep. So if we're given a perfectly horizontal line, we can also be given a perfectly vertical line. So if we're given the equation x is equal to 3, whereas to graph this function, or this line, should I say, That's a vertical line. For the graphic, my y-axis, my x-axis, we go to the right, 1, 2, 3. And this would be the vertical line, all right through 3 of the x-axis. Now, in this case, the domain for this function would be the set containing 3. That's the only x value we would have. Well, the range for this function would be the entire real number system from negative infinity to infinity. So it goes up and down forever, but it only goes through the value 3 on the x-axis. All right. Next thing we need to talk about is the standard form of a linear function. So then with the linear function, the standard form is the form ax plus by is equal to c. All right. So the easiest form to graph out of slope-intercept form, or y equals mx plus b. Keeping in mind that f of x and y are the same, it could also be presented as f of x is equal to ax plus b. That's the easiest form to graph out of. So we're given the standard form. We want to put it in slope-intercept form, the easiest form to graph out of, by solving for y. Right? So an example, let's say we're asked to graph the function 4x minus 5y is equal to 0. So technically this is presented to us in standard form. If we're going to graph it, it actually helps us to put it in slope-intercept form, or we can take advantage of the fact that if we're looking for the x-intercept, this implies that by y is 0. So here we will have, so we will have 4x minus 5 times 0, or 0 is equal to 0. 4x is equal to 0 because 4x minus 0 is 0 itself. Oh, excuse me, 4x minus 0 is 4x itself. And we solve for x, we end up with the x-intercept being 0. All right. Now, if it goes through 0 on the x-axis, this is also my y-axis, my y-intercept. So this means that this problem goes through the order pair 0, 0. So it actually will help us to solve for the slope now. Like we said before, we can easily put this in slope-intercept form by solving for y. So if I had, well, starting with the equation, 4x minus 5y is equal to 0, first thing I will do, subtract 4x from both sides. So I'm going to give me a negative 5y is equal to negative 4x. Then we can divide both sides by negative 5 to get the y by itself. So now we have a one positive, singular positive y is equal to a positive 4/5 x. And this will be my slope, 4/5. So we know it goes to the point 0, 0, or it goes to the origin. We also know that we have a slope of 4/5. So we can graph this. My apologies, but now we have our slope. We know it goes to the order pair 0, 0, goes to the origin. So we can get a good sketch of this graph. So we already know that it goes to the origin or the order pair 0, 0. From that point, we can go up 4 and to the right 5. Then go up 1. So from this point, we can go up 1, 2, 3, 4. And to the right, 1, 2, 3, 4, 5. But once we have 2 points, that's enough to define a line. So we can connect these points. And that's the graph of our equation, 4x minus 5y is equal to 0. Now our domain, the entire real number system, which is from left to right, all the way from negative infinity to infinity. Or our range is also the entire real number system. It goes up and down forever, or reaches from negative infinity to infinity. Right. So just focusing on the slope for a second. Remember that our slope, usually signified by that lowercase m, is our change in y over the change in x. Mathematics typically denotes this as delta y over delta x. But as far as our formula for the slope, this is what we're really going to be focused on. It's going to be y2 minus y1 over x2 minus x1, which would be the difference in two y's, or the change in y, and the difference in two x's, or the change in x. Some examples of this real quick. This is our slope formula. M is equal to y2 minus y1 over x2 minus x1. So a quick example of this. We're given 2 points. Let's say -4, 8, and 2, -3. And we're asked to find the slope. From the formula, M is equal to y2 minus y1 over x2 minus x1. Remember, if you know, I typically write out the formula every time just because it limits the mistakes. And the more you write it, the more likely it is that you're going to remember it. The most common mistake that I see in these problems, mislabeling the points. First number in every order pair, my x coordinate, second number is y. So this is xy, xy. My first x, my first y, second x, my second one. So now I properly labeled x1, y1, x2, and y2. And all I have to do is plug everything in its appropriate place. So here, this would be y2 or -3 minus y1, which is 8, over x2, +2, minus x1, which is -4. Remember, we subtract a negative. It's just like add. So essentially what we have, -3 minus 8, -11, over 2 minus a -4, or 2 plus 4, which gives me 6. So slope, -11/6. More of the same. This time we're given the points -3, 8. And 5, 8. First number x, second number y in the order pair. X, y, first x, first y, second x, second one. Plug everything into its appropriate place. Keep in mind slope formula, y2 minus y1 over x2 minus x1. So here, y2, 8, minus y1, also 8, divided by x2, 5, minus x1, which is -3. Notice the subtraction is a part of my formula. So if I subtract the negative, I must keep both signs. But remember, if we subtract the negative, essentially we're adding. 8 minus 8 is going to give me 0 over 5 plus 3, 8. So my slope ends up being 0 itself. All right. Keep in mind too, perfectly horizontal lines have a slope of 0, or it has no slope, where vertical lines are undefined. More the same. This time we're given the points -4, -10. And the points -4, 10. Go through a label, x, y, first x, first y, second x, second y. Plug everything into its appropriate place. the slope formula, y2 minus y1 over x2 minus x1, y2, 10, minus y1, negative 10, divided by x2, negative 4, minus x1, also negative 4. Anytime we subtract a negative, basically adding. So it's going to be 20, 10 plus 10, 20, over negative 4 plus 4 is 0. Remember, we cannot define or divide by 0. So this is actually undefined. So if we have an undefined slope, remember the slope is undefined, that's a vertical line. We do want to take note of this for vertical and undefined lines. All right, so focusing on slope, we have a horizontal line, or a line that goes from left to right. Then the slope is actually 0. So horizontal lines have a slope of 0. When we have a vertical line, or a line that goes straight up and straight down, that's going to be undefined. So we also could be asked a question like, find the slope. So if we're asked to find the slope, the easy way to do this is to take advantage of the slope-intercept form, or we could solve for y. This puts me in slope-intercept form, and now the number in front of x is the slope. Example of this, if we're asked to find the slope and given the equation 4x plus 3y is equal to 12. Easy way to do this, solve for y, getting the y by itself, making sure it's singular and positive, and then putting it in slope-intercept form. First thing I would do, subtract 4x from both sides. This is going to give me 3y is equal to a negative 4x plus 12. Keep in mind, these are not like terms. You cannot combine them. After that, divide everything in the problem by 3. This gets the y by itself. We have a singular positive y, which is what we wanted, equal to a negative 4/3 x plus 4. Now, the number in front of x is my slope. So in this case, my slope negative 4/3. Next thing we could be asked to do, graph line using the point and slope. So if we're given the point -2, -3, and we're told that the slope of the line is 4/3, and we're asked to graph it. Remember, the slope, top number is up and down, so we have to go up 4, bottom number is left and right, right 3. So if we're graphing this, first off, we can start the order pair -2, -3. So that's to the left, 2, down, 1, 2, 3. That's the point on my line. And from this point, we can go up 4 and to the right 3. So from this point, we can go up 1, 2, 3, 4, to the right 1, 2, 3. Remember, the slope tells us how to get from one point to another. We went up 4 to the right 3. Once we have 2 points, that's enough to define a line. So we just graph using the point and the slope. All right, last thing we could do, last thing we're going to be asked to do is find the average rate of change. Just remember that with the average rate of change, this has the formula. F of B minus F of A all over B minus A. Now, technically, this is still the change in Y, or Y2 minus Y1 over X2 minus X1. The arbitrary change is the slope. So we can just find our example problem here from the actual homework. Give me a second. For the investigation, I actually don't see any average change problems for the first homework section. So this is actually going to cover the 2.4 homework. It's going to be attached to Blackboard. This is the formula for average change. I'll probably start out the next section with a problem like this. I'll just pull one from the book. All right. So please start your homework, and I'll go over 2.5 and probably 2.6 in the next lecture. Hopefully, we'll be able to return to the classroom when I feel that better. All right. If you have any questions, feel free to email me, and good luck studying.